take a look at this example. Suppose we have the following two-dimensional object, x and y, and this is y equals to x squared. And as before, we want to know what is the approximation of the area below the graph between 0 and 1. Remember that if we use the sub-intervals and divide up the interval 0 to 1 to sub-intervals. And use the right endpoints, the larger approximation is denoted by R sub n. Now the example said, show that the limit of this R sub n as we make these sub-intervals smaller and smaller is going to be 1/3. This is what we're trying to show. So remember that we took this two-dimensional object and we divided that up into smaller rectangles. So here we have x and y, and this is our shape, for example, 0 and 1, y equals to x squared. 0 and 1. And then we start taking these small rectangles and we try to approximate the area of this two-dimensional object using the right endpoints. That's why we have larger rectangles. So if we add these together, suppose these are very small. If we add this together, the limit as these sub-intervals are getting smaller and smaller is going to be a third. So note that your function f of x is equal to x squared. You have sub-intervals on the right. What's the length of the sub-intervals? Delta x is defined as b minus a divided by n. What is a? What is b? These are the end points of your intervals. In this case, a is equal to 0 and b is equal to 1. So your delta x is equal to 1 minus 0 divided by n, or 1 over n. In previous example, n was 4. Now, to approximate Rn, Rn is equal to, so each of these lengths is 1 over n. So take a look at this. Here you have 1 over n, which is the base of your rectangle multiplied by the height. But what is the height? Well, to find the height, you're going to use the right endpoints. So here you have 1 over n to the second power. So here you have 1 over n to the second times the length, which is 1 over plus. What about the second endpoint? It's going to be 2 over n. So now here you have, the length is 1 over n, but the number on the right-hand side is going to be 2 over n because it starts at 0 and then you just magnify this so you can see what's going on. This is 1 over n, and now here you have 2 over n, but note that this length is 1 over n. Still, the lengths are the same. 1 over n, 1 over n, but to find this height, you're going to enter 2 over n. So here now you have 2 over n to the second power times 1 over n, plus the rest of these. But what's the last one? If you just keep continuing, this guy is n over n or 1, which I expect this to be 1. And the length is 1 over n. So plus n over n to the second power times 1 over n. So what are we trying to do? You're actually trying to create a series. Rn is going to be. So here you can, for example, factor out 1 over n. You get 1 over n squared plus 2 over n squared plus n over n squared. What else? Here I can factor out n squared as well. So Rn becomes 1 over n times 1 over n squared, 1 squared plus 2 squared plus n squared. Very good. Remember this sum from math. One over n cubed, and here you get n times n plus 1 times 2n plus 1 divided by 6. Very good. Now, if you take the limit from math 1a as n approaches infinity, the degree of the denominator and the degree of the numerator are the same. So it's going to be 2 over 6 for a third.